In section 2, we're going to talk more about sum of vectors. Now, we did talk about this a little bit at the end of section 1, but we're going to go into it a little bit more detail in section 2. So there is a geometric way to add vectors. So if you only have a picture of the vectors, you don't actually have the vector in component form, you can still add those vectors together. So the first method we're going to talk about is the geometric addition, the head to tail method of adding vectors. So when in this method, that means that you move one vector so its initial point is attached to the terminal point of the other vector. So it does involve moving the vectors. The resultant vector, so the vector we're trying to find when we add them together, it points from the initial point of one vector to the terminal point of the other. So I know it can be a little difficult to understand this with words, so I am going to draw a picture of this as well. So suppose we have our vectors A and B, and I want to figure out what happens when I add those two vectors together. I'm going to move vector A so that its initial point is now at the terminal point of vector B. So now we still have B, but now we've moved A. The vector I want to find starts at the initial point of B and ends at the terminal point of A. And C would be the vector I get when I add those two together. The second method we have for adding two vectors geometrically is called the parallelogram method. So in order to use this method, we draw the vectors so the initial points coincide. Then you draw lines to form a parallelogram. So our resultant vector, the vector we want when we add them together, is going to be the diagonal from the initial point to the opposite vertex. And similar to the previous example, I am going to show you what this means with a picture. So we have our vectors V, and suppose we have vector U. In order to find their sum, I am going to complete the parallelogram, and then my sum vector starts at the initial point and goes to the other corner of our parallelogram. So U plus V is that diagonal. But they do have to have the same initial point in order to use the parallelogram method. So we're going to briefly refresh our definition of scalar multiplication. So again, this was at the end of our previous note. So just to refresh, scalar multiplication is when you multiply every value of your vector by the scalar. And the reason why we're refreshing our definition of scalar multiplication is it's going to come in handy when we're subtracting two vectors. So when we are subtracting vectors, what we're actually going to do is use addition, where the second vector is pointing in the opposite direction. So what that means is, if I am doing A minus B, I can rewrite that as A plus negative B. So we take our vector B, multiply it by a scalar of -1, and then we use one of our addition methods. So subtraction is actually going to become addition of a negative number. So let's go ahead and take a look at an example. So we have two vectors u and v, and we want to draw our sum vector, u plus v. So we could use the head to tail method, but that would involve moving one of our vectors. This example is set up pretty easily for the parallelogram method because our vectors have the same initial point. So what I'm going to do is I'm going to draw my parallelogram. So there's my parallelogram, and then my sum vector u plus v starts at the initial point and goes to the vertex of my opposite corner. So this is going to be u plus v. It's going to start at 0, 0 and end at roughly about 8, 1. We can also do an algebraic addition of vectors. So if you have the component form of your vector, so they're written as position vectors also, you just add their coordinates. So if u is a1, a2, and v is b1, b2, then their sum would be a1 plus b1, comma a2 plus b2. And this is what we did at the end of those section 1 notes. So for example, given h is -5, 6, and k is -7, -9, we want to find h plus k. So h plus k is going to equal -5 plus -7, comma 6 plus -9, which is going to become -12, -3. And that is our sum. Next, we want to find 2h minus 3k. So we want to find 2h first. So 2h takes your vector h and multiplies it by 2. So remember, we distribute that 2 into the vector, so -5 times 2 and then 6 times 2, which is going to become -10, 12. And we also want to find 3k. So 3 times our vector, -7, -9. Which is going to become -21, -27. So now we can actually do 2h minus 3k. So remember, we rewrite that as 2h plus a -3k. Well, we have 2h, it's -10, 12. We just need to multiply 3k by -1. So -1 times -21, -27. So it's going to become -10 plus 21 and 12 plus 27 once you distribute that negative, because the -21 and the -27 will become positive. So we end up with 1139 as our vector. So after we have added vectors algebraically, we can still find the magnitude and direction of that sum vector. So we want to find the sum of our vectors a and b by adding, and then we want to find its magnitude and direction of the sum. So let's first start by finding a plus b. So we have to do 4 plus -2, and then 5 plus 9. So we are going to end up with 214 as our sum vector. So now we want to find the magnitude of a plus b. So that's just the square root of my x coordinate squared plus the y coordinate squared. So we get the square root of 2 squared plus 14 squared, which becomes the square root of 4 plus 196. Which becomes the square root of 200. Now we cannot take the square root of 200, but we can simplify it, and it's going to become 10 radical 2. Now we want to find the direction of our vector. So the angle it forms, so theta equals the tangent inverse of b, which is 14, over a, which is 12. So using a calculator, making sure it is in degree mode, you do the tangent inverse of 14 over 2, and we get theta equals 81.87 degrees. And then lastly, we remember from direction, you have to check the quadrant you're in, and then 214 would be in quadrant 1, so we don't actually have to change theta, because in quadrant 1, theta is theta. So we have a magnitude and we have the direction of the sum. This is specifically of the sum vector. So last example we're going to do is how to find a position vector from its magnitude and direction. And we're going to use trigonometry to do this. So given a diagram of forces acting on an object at the origin, so it's some object that has forces acting upon it in different directions, we want to find the resultant vector, so the sum, and describe the motion of the object. So we have 3 different forces here. One's going straight east. It's got a force of 10 newtons. One's going south, and it has a force of 10 newtons. And then we have a vector going in a northwest, a force acting like northwest, and it's got a force of 11.43 newtons. And we know the angle here is 150 degrees. So all of these numbers are the magnitudes. They are not the vectors. So we have to find those x and y coordinates. And what we're going to do is we're going to use trig. So I'm actually, if I can draw my vector that we have, I'm going to call this one force 1. I can draw that vector as a sum of an x and y vector using that head to tail method on that first page of the notes. And when I do that, I get a right triangle. So the x coordinate and the y coordinate can be found. And then the angle here, because we know the positive direction is 150 degrees, we know this angle is 30 degrees. So we can use trig functions to help us find the component form of that vector. So we know that in order to solve for x, we have to use the adjacent side, and we're given the hypotenuse. So we know cosine, since cosine involves adjacent side, we know cosine of 30 is going to equal x over 11.43. Solving for x by multiplying, we get that x equals 11.43 times the cosine of 30. Then you just use a calculator, And we get that x is 9.9. But if you notice, this vector is in quadrant 2. And in quadrant 2, x should be negative. So we're going to add that negative there so that we have the correct x value. All right. Now we're going to do the same thing for our y value, but in order to solve for that, we have to use sine, because sine is opposite over hypotenuse. So sine of 30 equals y over 11.43. Multiplying both sides by 11.43, we get y has to equal 11.43 times the sine of 30. And again, using a calculator, we get y equals 5.7. So we actually have enough information here to write our vector f1 as negative 9.9, comma 5.7. So now we just have to find our other two forces. So I'm going to label these F2 and F3, and then we can add them all together to get our answer, because then we can use our algebraic method. Well, our x2 vectors, they are on an x-axis and a y-axis. So it's pretty easy for us to put our vector in component form. So this has an x value of 10 and a y value of 0. And our third force has an x value of 0 and a y value of negative 10. So ones on the x or y axis are easier to write. So now we want to go ahead and find F1 plus F2 plus F3. So we're just going to add all of our x values. So negative 9.9 plus 10 plus 0. Then we add our y values, 5.7 plus 0 plus negative 10. And we end up with the vector 0.1, comma, negative 4.3 as our resultant vector. So I'm going to go ahead and draw this so we get an idea of what that vector looks like. So 0.1, it's not very far, negative 4.3. So we're going to start at the origin, and our vector is going to look a bit like that.